Hello everyone, today I will introduce my project. It's automatic frequency scale for embedded core persist acceleration. And this project is so interesting and so special because it will touch with hardware. And it's beside on the NVIDIA Zheqi board. It's the low power platform, and due to this advantage, it can use some special air field like the automatic driving car or maybe robot system. However, this field is sensitive with the power consumption, so we should to think about how to energy saving. And due to this question, we first use the power monitor function to collect the hardware data. It can to get the 10 step, totally power, GPU power, CPU power, and the 4 cores different frequency and the GPU frequency in the final. However, we analyze the original collected data. It's just can to get currently this the line chart, and we can look for this just only the linear relationship. It can't get the best the frequency and the power consumption relationship between this data. We should think about how to analyze it. We want to use the machine learning algorithm to do it. So the first we use the K-means algorithm. It's the unsurprising learning algorithm. It's by the cluster analysis. In our CPU frequency is the 4 steps for the different frequency, and the GPU frequency has 13 steps. And with the first, we think about focus on the GPU frequency is the 13 and classed by the K-means class. So we get the 13 class by different totally power consumption. Okay, this state is the different with original collected the totally power value, because we use the K-means should have the huge different filter. So the value is 10 times for the original one. That's all right. We can see it back in our calculation. So we just focus on calculate this the 13 class, and we manually think the average one is the best power consumption and the best performance. So we see it in this the number 7, the class. Is the positive the data state simples, and the last one is the negative the data state simples, because due to it's too high and too low for the power consumption. When we get these two data states, one of the negative and one of the positive data states, we send to the Random forest algorithm to analyze again. This algorithm is the machine learning, and we finally can get to classify to predict the new data. And for example, we can look for use the power monitor function to collect the programming the new date, the hardware date, the information, and send to this the training classify, and the classifier will answer this input the new date and the hardware date. For example, we input the new currently the CPU frequency and the GPU frequency put to the classifier is will answer the T and F. T is 2. This means currently the frequency is sitting good and don't need to change. But if answer is the F is 5, so this mentioned currently the frequency is not good option. We should to change frequency. Finally, we just want to get this classified answer is T. So anytime we get the F for our the new collected the power monitor date, we should to change the frequency and the currently the GPU and the CPU frequency. So right. So for calculation, we can combination this the power monitor function with the random forest this classify. When every time running the power monitor function gets the date, just send to the random forest this classify, and we one by one to test. Finally, when the classifier gets the T, the 2, this result, that means currently the project is, the frequency is good. It's the best option and the best the power consumption. So that is the automatic the frequency scale, the function is done. Okay, yeah. Thank you for your listening. This is my project.